This is next article, monostable multivibrator. In that case, we'll firstly explain circuit diagram of monostable multivibrator and its working. And from the output of monostable multivibrator, we find the pulse width. Monostable multivibrator is another electronic circuit designed with IC555. Its name is monostable since it has only one stable state, and it is also known as one-shot multivibrator. Now, its circuit diagram is shown here. The working of monostable multivibrator we explain with help of earlier discussion of IC555. That IC555 is connected externally to RC, resistor, capacitor, supply, and then we find its output at terminal 3. Now, how external connections are given here. Reset terminal 4 and supply 8 connected together and given to positive supply VCC. That supply may be in between 5 volt to 15 volt. The external resistor R is connected in between supply, positive supply, threshold pin 6 and discharge pin 7. Another component capacitor which is connected in between threshold pin, discharge, and another terminal of capacitor is connected to ground. Control pin is given to capacitor whose value is 0.01 microfarad. Its other end is grounded with pin 1. That capacitor which helps to avoid noise in the actual circuit. External trigger is given at pin 2 and output is measured at pin 3. As per our earlier discussion of working of IC555, the result we know when flip-flop state is reset, the output of timer becomes low. When flip-flop state is set, output of the timer is high, and when it reset, it depends upon input of the flip-flop, that means output of the two comparators that we use for explaining the output of the monostable multivibrator. Here, the output voltage across the pin 3 is shown here, and also simultaneously we explain the capacitor voltage. Initially, when monostable multivibrator is low, that state we call stable state. Here the voltage on capacitor is 0. That multivibrator remains in that state until external trigger is given to that circuit. Now when external negative pulse which is applied at the pin 2, then what happens? The output of the lower comparator is second, it will becomes high. That is S is 1, R is 0, and output of the flip-flop is 0. If output of the flip-flop is 0, then the discharge transistor to be turned off and the output of the timer becomes high since output of the flip-flop inverted and it gets high. At this condition, we know the output of timer becomes high here. At this condition, what happens? The capacitor gets charging. That charging goes on increasing exponentially through the external resistor R. Therefore, the time constant of circuit we call RC. When the capacitor voltage reaches up to the 2/3 VCC and it is slightly higher, then output of comparator 1 becomes high. Output of comparator 1 becomes high, that is 1, and output of comparator 2 is 0, and output of flip-flop is 1. Q bar is 1. If Q bar is 1, output of flip-flop is 1, then discharge transistor turn on and capacitor start to discharge. That state, flip-flop state, is a reset state, and output of timer is low. That output of timer becomes low here. Flip-flop state is a reset. In that case, what happens? When the transistor T2 is turned on, the capacitor discharge instantly and it suddenly drops down to 0. And the output of timer goes from high state to low state. This high state we call quasi-stable state. It is unstable state. Low state is stable state. Hence, out of the multivibrator goes from stable state to quasi-stable state, and that is continued when the next trigger is given to at pin 2. Hence, output of timer becomes low whenever it becomes low until next trigger pulse is applied. In this way, for every trigger pulse, the output of monostable goes from high state to low state. That is, causes to stable, stable to again causes state to stable state. That process cycle is repeated up to the applying next trigger to the circuit. Now, what is quasi-stable state? That quasi-stable state is temporary state. Hence, we call it is unstable. The width of the quasi-stable state, it gives the actual pulse width of the monostable multivibrator. Hence, the pulse width of monostable multivibrator, it depends upon time constant of the circuit. And what is the time constant of the circuit? If capacitors start to charge through the resistor R, the time constant is RC. Hence, width of the pulse or width of quasi-stable state, it depends upon the time constant RC. What is the relation for the pulse width? That we find here. To find pulse width, we define pulse width, the duration for which the high output remains in quasi-stable state. For that, we define one relation. The capacitor voltage Vc is given by the relation Vc equal to Vcc into bracket 1 minus exponential minus T by Rc. Here Rc is the time constant, Vc is the capacitor voltage. That voltage increases up to the 2/3 Vcc. Therefore, Vc replaced by 2/3 Vcc, and we write relation. Cancel Vcc on both sides and simplify. this exponential term separate from that relation, that exponential minus t by RC equal to 1/3 term. Therefore, taking log on both sides and simplify, t equal to RC log 3. Log 3 is 1.1, therefore pulse width t equal to t on equal to 1.1 RC. In the pulse width of the monostable multivibrator, it depends upon the value of R and C. And that is the result of monostable multivibrator. Thank you.